Hello children, this is your science class and we are discussing chapter number 11, Human Eye and the Colorful World. In the last class, we discussed about some of the beautiful phenomena in nature like twinkling of star, then formation of rainbow, then advanced sunrise and delay in the sunset, and all these phenomena were related with refraction of light in the atmosphere. Today's class will be again an interesting class because we are going to discuss some of the wonderful things which we observe in nature, and these things are because of the scattering of light. So let's go ahead with the topic. We are discussing chapter number 11, Human Eye and the Colorful World, and today's topic is scattering of light. So children, when we say scattering of light, it is the spreading of light in all possible random direction. Now to spread the light, how does the light spreads? It's because the Earth's atmosphere, it's a heterogeneous mixture of so many minute particles. These particles are air molecules, dust particles, water molecules and smoke. And these particles are responsible for scattering or spreading the light. You all have learnt in standard 9th that when a beam of white light is passed through a true solution, the white light is not visible. However, if this beam of white light is passed through a colloidal solution, then this beam of light spreads in the colloidal solution. The reason is the particles of the colloid, they are responsible for spreading this white beam of light. So on the screen some images are flashing. Please see the images wherein you can see that the two beakers are kept side by side and a white beam of light is allowed to pass through the beakers. And the beaker which has colloidal solution, there the beam of light is clearly seen, and the true solution, in the true solution the beam of light is not visible. So this phenomena of scattering or spreading the beam of light due to the particles present in it is called as Tindal effect. So I can define it like this, that when a beam of light passes through a colloidal solution, the path of the light becomes visible due to scattering of light by the colloidal particles. And this phenomena is called as Tindal effect. And Tindal effect was first discovered by an Irish physicist, John Tindal. Now children, if the colloidal particles are scattering or spreading the beam of light, the sunlight which is entering into the Earth's atmosphere is scattered by the particles present in the atmosphere. So we can observe Tindal effect in the nature also. We can see Tindal effect when a beam of sunlight enters a smoke-filled room through a small hole. Children, I want all of you to have a look at the first image flashing on the slide. In this phenomena, the scattering of light makes the particle visible. Tindal effect can also be seen when the sunlight passes through a canopy of dense forest. And in this case, the tiny droplets which are present in the mist scatters the light. Now all the small particles present in the atmosphere, they are scattering the light. But we all have discussed that sunlight is a combination of 7 colors. There are 7 colors present in the sunlight. So when the light is scattered in the sunlight, why is it so that we can't see all the 7 colors? The reason behind this is the scattering of the light depends upon the size of the particle. If the size of the particle is very small, this particle spreads or scatters blue light. Large particles scatter different colors of light. If the size of the scattering particle is large enough, then the scattered light may be white in color. Now generally it is said that the blue color scattered to the greater extent in the atmosphere as compared to the red light. This is because the wavelength of the blue color is very small as compared to the wavelength of the red color. Now let's understand what is this wavelength. Children, you all are aware that light travels in the form of a wave, and it is an electromagnetic wave and it looks like a transverse wave. So the 7 colors of the light are shown in the form of a wave. I want all of you to have a look at the figure which is flashing on the slide. The 7 colors of the spectrum are drawn with the wavelength they travel with. So from the image you can make out that the red color is at the top and the violet is at the bottom. Now when we say wavelength, the distance between alternate crest and trough is called as wavelength. So if you see every color, you will observe that the wavelength of the red color is maximum and the wavelength of the violet color is least. So the colors which are present at the bottom of the spectrum, they have smaller wavelength, and the colors which are present at the top of the spectrum, they have the greater wavelength. Now how is this wavelength and size of the particle is related? If the size of the particle is smaller than the wavelength of the color, then that particle spreads that particular light. It is observed that the particles present in the atmosphere, the size of those particles are smaller than the wavelength of the blue color, and that is the reason blue color spreads maximum in the atmosphere. So the air molecules like oxygen molecules, then nitrogen molecules present in the atmosphere, the size of these molecules are small as compared to the wavelength of blue light. So these molecules, they spread or they scatters blue light. But the smoke particles, the dust particles, the water molecules, these particles have the size which is larger. So when sunlight falls on these particles, they spread the light of all colors. And when this light comes to us, it is a mix of all 7 colors, and we see that light as white light. Right, children? So I hope you understood the relation between the particles, small particles present in the atmosphere, and the wavelength of the light. Alright, so one thing you have to keep in mind, that the air molecules like oxygen molecules and nitrogen molecules, they are responsible for scattering of the blue light, and the water molecules, the dust particles and the smoke, these all are responsible for giving out the white light or spreading the white light. So with this explanation now, it's easy for us to explain why sky looks blue in color. So just now, like I explained, that the fine particles, the very small particles in the atmosphere, they have the size which is smaller than the wavelength of the blue color or the visible light. So they scatter blue light which has shorter wavelength than the red color which has the longer wavelength. So when the sunlight passes through the atmosphere, the fine particles which are present in the atmosphere scatter the blue light more strongly than the red, and so when we look around everywhere, we see that it's most of the blue color, and that's the reason sky appears blue in color. One more thing I want to mention here, children, that the reason for sky appears blue in color was explained to the world for the first time by an Indian scientist, and that is Dr. C.V. Raman. So we should feel proud of this, that the explanation, the scientific explanation about why sky looks blue in color is the explanation given by the Indian scientist. Now sky looks blue in color, but the clouds which are there in the sky, they are white in color. What is the reason for this? The reason is the clouds are relatively at the lower height as compared to the sky, and therefore the clouds, they scatter the particles which are present in the lower atmosphere of the earth. Now the clouds are made from, or the clouds consists of dust particles, water droplets and ice particles, and the size of these particles are large as compared to the wavelength of the incident light from the sun, and so there is very little scattering of light. Rather, we can say that all the wavelengths are scattered equally. All the colors of the white light scatters equally, and therefore the light which we receive through the clouds has all the colors of light, and the result of this is the cloud appears the cloud appears white in color. Right? Now during the storms, you must have seen that the clouds appear black in color. They appear black or gray in color. The reason for this is, at the time of the storms, the cloud becomes very heavy. The thickness of the cloud increases to the larger extent, and so when the light falls on the cloud, the light gets trapped at the bottom. So the light doesn't pass through the cloud, and as a result the cloud looks dark or gray at the time of the storm. But at night, when you look at the sky looks dark. It looks black in color, because at night there is no light, and since there is no light, there is no scattering. Now imagine, children, if there wouldn't have been atmosphere around us, the sky would have looked absolutely dark, because to scatter the light, the particles should be there, and the fine particles are present only in the atmosphere. Then if the astronauts look into the sky, there is no atmosphere in the space, there is no air in the space. So since there is no air, there are no fine particles there, so there is no scattering of light. There are no particles which can scatter the light. So the astronauts can observe the sky as completely dark in color or completely black in color, right? Now look at this slide. You can observe some of the important signals and the messages which should reach to the people quickly. And these messages are printed, or they are colored in red color. The reason behind this is the spreading of the red color is least. Red color spreads very less because its wavelength is maximum. And so the important signals, the important messages which should be flashed and should get the attention of the people faster should always, it is always given in red color. Right, children? Now let's understand the reason behind the beautiful red color of the sky and the red color of the sun at the time of sunset and sunrise. So at the time of sunset and sunrise, we observe that the sun and the sky around the sun looks reddish and yellowish in color. Now what is the reason for this? The reason is, at the time of sunset and sunrise, the sun is very close to the horizon. So when the rays of light travels from horizon to the observer or to us, the light has to travel a very long distance. And during this long journey, most of the blue color light is spread out by the fine particles present in the atmosphere. And what is visible to us is only the color which has maximum wavelength, and that is the red color. And so when at the time of sunset and sunrise, when the sun is very close to the horizon, we observe the color of the sky as red. But exactly opposite to this, when the sun is overhead, at noon, when the sun is overhead, the sunlight is white in color. The reason is, when the sun is overhead, the sunlight has to travel relatively smaller distance to reach to us. So during this short journey of sunlight, only a little of a blue color of a light is scattered. And since the light coming from the overhead sun has almost all its component color in equal proportion, the sun in the sky overhead appears white to us. So with this, our explanation for the scattering of light is over. I hope you understood, because the concept is based only on the size of the particle and the wavelength of the color of the light. So I hope you liked it, and now it's easy for you to understand why there are several colors which we see in the sky. And I must say that this is the right time for all of you to have a look outside the window and see beautiful colors which nowadays we can see in the evenings. And then you can explain the reason for this to your parents and to your friends. So let's have a quick quiz on today's topic. I will read some questions for you. Please be ready with pencil and a book. You just have to write the answers in the notebook, and towards the end you have to tally your answers. So your first question is, what is the color of the sunlight which is scattered by the dust particles in the atmosphere? So you just have to write the color of the light, right? Then the second question is, what is the color of the sunlight which is scattered by the air molecules in the atmosphere? Done? Then your third question, state two effects which are produced by the scattering of light by atmosphere. So which two effects are produced by scattering of light in the atmosphere? We have learnt one today and one in the previous session. Okay, so please write down. Your third question is, which of the two is scattered more easily? Light of shorter wavelength or the light of longer wavelength? So just write the answer. Next question, which effect is illustrated by the observation that when a beam of light enters a dusty room, then its path becomes visible to us? You have to write down the name of the phenomena. Alright children, so coming to the last question, by how much time the day would have been shorter if the earth had no atmosphere? I repeat once again, by how much time the day would have been shorter if the earth had no atmosphere? So please write down your answers. You have to tally. The answers are flashing down there on the screen. Check your answer, and I hope you got all correct. With this, we will stop for today's class. In the next class, we will discuss some new things, and see you then. Bye and take care.